Myself, Srinivasan, working as a faculty in the Department of Mechanical Engineering at Sri Shanmugha College of Engineering and Technology. I'll be talking about gradient descent algorithm using Python. Gradient descent is an optimization technique that helps to minimize the loss function. So now we will see how to do using Python code. We have used the NumPy. Since we use numerical calculation that we have imported this NumPy library, then we are going to see the plot. So that's the reason we have used matplotlib functions, and we are going to look at using the 3D plot. So that's the reason we have imported this one. So we have input features zero point 0.5 and 2.5. There are two inputs, and similarly we have two output as well. Okay. So this is for the case of sigmoid activation function. It is basically 1 by 1 plus e power minus z. The z is basically your wx plus b. That is a weight, that input plus bias. Okay. So the last function can be, already we discussed many times. This is the last function. This is L by 1 by 2 squared difference between your predicted minus actual one. Okay. So when you differentiate with the loss function with respect to weight, and we will use that chain rule. In that case, we will use this dou L by dou F by dou Z, and dou Z by dou W. Okay. So when you differentiate this one, we will get this, and when you differentiate dou F by dou Z, so dou F basically a sigmoid activation function over here. Then when you differentiate this is a derivative of the sigmoid activation function f minus y and function of 1 minus f into x. Okay. And similarly, when you differentiate this one, the inside whatever we have dou Z, this is Z, and you will have only x. Okay. So that is, since we use the two input values, and we use this function, and we will try to find the error. And similarly, when you go for derivative of loss with respect to weight, this is the one we have used. So the similar one we have used here, and this is for the case of bias. So in the with the help of gradient descent, we update the weights. This is a new weight, this is a old weight minus learning rate, and change in error, change in loss, or like gradient of loss with respect to weight. And here the loss function, gradient of loss with respect to bias here. Okay. So initially we initialize the weight is -2 and eta is 1, and we use this. Since we have two samples, the number of iterations is going to be 1000. We are updating all the weights for the visualization here, and we have the range of functions. So maximum, this one is, we are updating the weights over here. Updated weights are here, right? Updated weights are going to be in this function, in this variable. Okay. So basically, since we have two samples and we are updating the weights, and finally we are trying to find out the error. Okay. So this is for the case of 3D plot, we use this -3 to 3, and b is -3 to v and 50 grids. So we use this one, and for the error surface we use this one. What we have, this will take the values from here. Okay. And this value, updated weights and bias will be taken from this value. And finally, when you plot using the 3D one, and using the matplot library, then the initial point is here, and when you apply this, when the model parameters are getting changed, and finally it moves in the direction where it will get converged. Okay. So finally it reaches over here. So that is